All right, Brandon and Landon, here's a short video describing first the spatial extent of running the grain size mapping tool. So I shared with you guys a Google spreadsheet just moments ago, and this is it here. It's kind of a heinous looking spreadsheet, but I think the fields that you guys need to know about are Huck name ID, Huck name field, excuse me, and then the priority here. And I think you guys can add a field for the grain size mapping and for the hydrologic regime. But the idea is I want you guys to run it for all the high and medium priority watersheds, starting with high and then moving on to medium. And if it takes too long, I guess we could forfeit and not do the mediums, but in talking to Joe, I think we'll give that a try. So starting with the grain size mapping tool and then moving on to the hydrologic regime mapper. And that'll be just in Washington for the hydrologic regime. Okay, so now moving on, we're going to look at box where this data can be found. I guess first we could just look at what this looks like spatially. So all the blue and yellow, blues are high priority and yellows are medium priority. These will be the areas where you guys work. And once these are done, you'll have a map similar to this to provide BPA, Bountiful Power Administration, for the funding they provided. All right, so moving on to box. So where we can get the data set, so if we go into it all, projects, USA, and then within CHAMP, we have a subfolder called Analysis Tools, and you can go to Network Update RCAT 1.0.7, and within this folder we have things broken out by the watershed. So what I'd suggest is to use that tracking spreadsheet to find out which are high and medium priority watersheds. Working with the high priority first, go in. And so for example, Wenatchee, go into the Wenatchee, and the data, you guys basically will need a DEM and a network. So if you go in the VBET folder and then go into that particular watershed folder, and by the way, this naming convention, when you guys run your tool, use the same, name it with the same naming convention. So it's add all, it's the actual 8-digit Huck name as a integers as the values, and then underscore, and then call it GS mapper, grain size mapper, GS mapper. But within here, back to the data. So if the input data you'll want is in here. So your network is here and the topo is here. And so what I suggest is just using these inputs that are in here. You could copy this data, so you could actually just copy these folders over if you want to. So this is the perennial network. So you'll want to create your own folder structure for this. So, and I'd model it after some of these other tools. So for example, you could use VBET as your example. You could call it GS mapper, and then you'd have your inputs, and then as you run it, your analysis outputs. So it brings up the point that, I mean, maybe one thing, and this is a little off topic, but these are all project enabled outputs. I mean, maybe Brandon should be thinking about, if he hasn't already, making these outputs in the format that are, like the XML that he's created for some of Sarah's tools. But we can talk about that later. This is probably enough to get you started. One thought is on box, we should probably give you guys better permissions for this folder, I can work on that. But in that case, if you end up deleting something, go into your trash and retrieve it. So if you were to delete a folder by accident, you go into the trash folder and you could restore it. Because otherwise, what happens is in several months, like 2 months down the road, it'll be permanently deleted. So if you accidentally delete something you don't want, go to trash, retrieve it. Alright, so this is probably enough to get you started, and we can talk more about this, but in talking to Joe, this is, good high priority stuff to be working on. Alright, thank you, gentlemen.